33, search in rotated sorted array. So the problem wants us to find the target value in given um, rotated sorted array. So if we use an approach of searching one by one, we can find it easily. However, in that case, that the time complexity will be O of n, where n is all values in given nums array. The problem wants us to find it in O log of n. So for this one, we will need to use a binary search. However, in basic binary search, when all arrays numbers are sorted, we can easily find it. In this case, there is a rotation in unknown pivotal point. So what we have to do, we still have to go and define low and high elements of the array and split it in half. And when we split it in half of this array, we can compare the low with the middle one and high with the middle one. And depending, let's say it's like if low is smaller than middle, then we can say that the left hand side of it it's rotated, and if the high side is let's assume if the high side is bigger than the middle one, we can assume the right side is rotated. And so what we are going to do is we will split it in half, then we will try to find the values on the left side of the sorted array. If it is not found on the left side of the array, then we'll go to the right side. So let's jump on. So as I was saying, let's define the low index, high index num, and we will just iterate until this is true, until left side is smaller or equals to high. And from here, so first we could just if we find so let's calculate middle element, middle index, so divided by 2, so this is our middle index. And in nums, if we find the target right away, then there is no need for us to search the rest of them elements, because we find it right away. Else if we'll define another condition, so we will start off from the left side, so nums L, if it is smaller or equals to nums M, we'll go from the left side. We'll need to set some conditions in here to try to figure out if we want to move the left side, if we want to search in the left side or we want to search on the right side. So in order to find it, we'll need to figure out if target lays in this range. So if target, because we're on the left side right now, if target is larger or equals to LA, or and if target, because we want to find if target is in this given range on the left side, so target is smaller than nums middle. So if it is on the left side, then we will need to update our high index. So our high index would be updating it, and instead of high index being, I'm just using kind of like this array. However, value, do not pay attention to the values. I'm just using it as an example. So if it's in the half, so high was initiated in here. So target, if let's assume target lay in this range right here, then we'll be updating high to be here in the middle. However, if target is not in this part of the array, then we'll search the right side of it. So, so in this case, if it's on the right side, then we will need to update our low to start from here. So low would be adding it, and this was the start of the left side. Then if we start from middle to the highest side, then also we'll need to figure out the target if it is smaller or equals to nums high, because you cannot exceed high, and target is larger than nums n. So we're looking at this range right here. And as just like above, so if it is on the right hand side, if it lays in this part of the array, then we'll need to update the low to match it to be here. So low equals to n. Otherwise, if it is not on this side, we'll need to search the left hand side. So high will come down to here. High. So if we don't get anything, we need to output -1. Let's run our code. Let's submit it. So basically the time complexity in this approach is O log of n, where n is all values in given num